Go to example 2. Again, it says solve by graphing, but this time we have parabolas. So again, I'm going to color code things here. The easy one would be y equals 3. The harder one to graph would be the absolute value of 3x squared minus 3. And in order to graph that one, I would first have to graph the inside, and wherever it was negative, flip it up. So, as far as starting, wow. Attempt number 3, the black line. Y equals 3. That's easy to graph. Horizontal line. To graph the blue graph, I first have to graph the inside. So 3x squared minus 3. This is a parabola. It's already in standard form or vertex form. Can you see from this that your vertex is at 0, negative 3? And because we have an a value of 3, we would go over 1 up 3, over 1 up 3, then over 1 up 9, over 1 up 9, and here is our orange graph. Then our blue graph, which is the absolute value, would be the same as the orange graph wherever the y values are positive. So this part would stay the same. And wherever your y values are negative, that's going to get flipped up. So 0, negative 3 is going to get flipped to 0, comma 3. Can you see that we have 1, 2, 3 solutions? The x equals 0 is really easy to see. The problem with the other ones is it's somewhere in between 1 and 2. And I can't tell from my graph this way exactly where it is. So what I'm going to need to do is I'm going to need to go to my graphing calculator and type it in. And I'm going to show you how to type in the second one. Because those of you that have a graphing calculator, do you know where the absolute value bars are on the graphing calculator? You have to hit the math button and then go over to number. And this is absolute value, not abs. It's not the stomach muscles of the calculator. So, once you have that, then we can type in 3x squared minus 3. And when we hit graph, it draws it nicely. Now, we already knew that x equals 0 is the answer. We want to find the other answers. So we can do that by going second, calculate, number 5, where they intersect. And you can do this on Desmos too. On Desmos, you just click on it and the dot appears and you just click on the dot and it tells you right away. On your graphing calculator, it will always find the one closest to your cursor. So you notice how I move my cursor over to that positive one? Now, first curve, push enter. Second curve, push enter again. Guess, push enter again. And we get 1.414 comma 3. And by symmetry, because parabolas are symmetrical, this will be negative 1.414 comma 3. So our solutions are x equals 0, x equals 1.414, and x equals negative 1.414. Does anybody recognize the number 1.414? It's the square root of 2. Okay, we're going to look at the algebra for this one. Okay, that was graphically. And again, I'm going to show you the algebra and you're going to be like, oh, I like the algebra better. That's okay. But it will ask you to solve some graphically. So algebraically, this is what would happen. We had 3 equals the absolute value of 3x squared minus 3. So there's 2 possibilities, right? You have the possibility, and you don't have to show this along the arrows. I'm just doing it right now so that you can, when you're studying, you can see this. We have the 2 possibilities. Either the 3x squared minus 3 is positive, or the 3x squared minus 3 is negative. If it's positive, the absolute value wouldn't matter. Then it would equal 3, right? And you'd have 3x squared minus 3 equal to 3. If it's negative, then what would the 3x squared minus 3 be equal to? A negative 3. Because if it was negative, the absolute values would make it positive. So if the inside was negative 3, it would still work. In solving these, how do we solve? Well, we combine our like terms. So here I would get 6 equals 3x squared, divide by 3, and I would get x squared equals 2. And here I would square root, and sure enough, there's our square root of 2. And when we square root both sides, we have to remember the plus or minus. And then we got our 1.414 and our minus 1.414. And this one, combine my like terms, add 3 to both sides, get 0, divide by 3, still get 0, square root, still get 0. So the algebraic way, right? This one you needed a graphing calculator or Desmos if you wanted to solve it graphically. Because it's not obvious from the graph. Ooh, looks like square root of 2. Okay? But algebraically you were still able to find it. You're going to get mad at the textbook just a little bit with the next question, part B. You're going to be happy if you get this question on a test and I say solve algebraically. Plus 4x. But we'll solve it graphically because it said graphically. Okay? Algebraically, this is all you would have to do. What does an absolute value do? It makes the number positive. Can it ever equal negative 2? So, algebraically, all you have to do must be positive, I guess technically positive or 0. You would be done. Question done. But this question said solve it graphically. And because it practices a lot of good graphing skills from chapter, did we graph in chapter 4 or 5? 4. It's good to practice this. It's frustrating because we already know the answer, and algebraically you would need to show absolutely no work. But it's said graphically. So that means I'm going to color code things. I'm going to graph y equals minus 2 in green. I'm going to graph y equals the absolute value of 2x squared plus 4x minus 1 in blue, which means I will have to first graph the inside in orange. So, here's my graph. And the green is super easy to start with. Y equals minus 2 is right there. Now graphing the orange. Notice that it is not in vertex form. So we have to complete the square to get it into vertex form. Oh, I saw some eye rolls, like, yay, so excited that this is going to happen. Do you remember how to change it to that? So you would factor out the 2, but only out of the first 2, giving you x squared plus 2x. You would still have your minus 1 after. Then you would leave a space here and leave a space there. We want this squared for vertex form. The 2x is the hint that this has to be x plus 1. If it's x plus 1, you needed a plus 1 in there to make it work. But that's why we also have the space on the other side. If you add 1, you have to compensate. But we also have to be careful we haven't just added 1, we added 2. So to compensate, we'd have to subtract 2, giving us a -3 here. So now it's in vertex form. My vertex is at -1, -3. My a value is 2, so it goes over 1, up 2, over 1, up 2. Right there. Then it would go over 1, up 6, over 1, up 6. And there's our orange graph. So then the absolute value would say where it's positive stays the same. And where it's negative, it would get flipped up. -1, +3. All right. All of that work to say, where does the blue graph and the green graph intersect? They don't. No solution. Now we've solved it graphically. So can you see why the algebraic way is like way nicer in this situation? But this was good practice, right? Because all of that completing the square, and that's going to come up on your white belt and your yellow belts as you're doing your reviews. All right, question number 2, circle 5B and 7.